Hello everyone, my name is Kyle, and I'm here today to talk to you about the VizQL Data Service from Tableau. Now, some of you might be asking yourselves, Kyle, didn't you already do a video and a post about VDS? And yes, I did. In August of last year, I was lucky enough to be a featured author on Tableau.com about the VizQL Data Service, where I did some examples of some of the things that you could do, and I didn't really go too deep into the technical details. And that's because at the time, the service was still in a beta. It was still rolling out only to specific pods on Tableau Cloud, and it didn't really make sense to do a deep dive because we knew a lot of the way things worked and the functionalities, the calls you made, things like that would be changing. But the good news is it's now in GA across all of Tableau Cloud, and it's coming to Tableau Server when you upgrade to 2025.1 and beyond. So it's a perfect time to dive right in. So let's do it. Now, naturally, one of the first questions you're going to ask yourself is, how the heck am I going to use this, right? I already know how to get data from Tableau. I can use the REST API. I can embed things and use the embedding API to make calls to get data about the marks on a dashboard or a view. And then maybe I'll just hide it and then just use that data to do whatever I want. That's clunky. It's weird. It's 2025. We don't need to do stuff like that anymore, right? So I'll give you the too long didn't read version of the post that I did last year. And then if you're interested in going further into some of the possibilities I explored and some other ideas to get you started, look for a link up there or over there or down in the description. I'll make sure that you can get to it. But here's how I would sum it up, right? The VizQL Data Service gives us the ability to programmatically query our published data sources. And what I mean by that is we're just writing a query, in this sense in JSON, where we're defining the fields that we want, how we want them sliced and diced, and then telling the API, just give me this data back in JSON. And the great thing about it being JSON is it's a web standard. It's something that lots of folks in development are already really familiar with. It's fairly easy to pick up on. And it just, once you have it in JSON, you can do just about anything your imagination can come up with. I'm also looking at you, fans of embedded analytics, the scenario that I gave before. Don't do that anymore. Let's just use VDS. Also enthusiasts of Python and R for data science. This is a great way to get that data just unleashed from Tableau without having to do something like download a CSV first and then use pandas or something to make it into a data frame. You know, all those unnecessary steps. Just tell Tableau you want this data in JSON and it'll give it to you. That's the great part. On top of that, we can trust this data, right? It's coming from sources that we already know. It's using the same governance and security when it comes to user roles and groups and things like that, that we rely on when we interact with Tableau in the UI and in the other APIs. So why not trust that data and use it to build wonderful, amazing things? You're going to see some of that hopefully later in the video. And let's just dive right in. Why don't we? A couple things to know as you get started with VDS that are really important is how to deal with authentication and permissions. So when we talk about authentication, I have good news for you here. It's the same. If you're used to interacting with the REST API, the Metadata API, or even TSC with Python, once you sign in, you get an API token, right? That API token is what you'll include in your request to VDS, and you're on your way. You don't need to do anything special. If you need a refresher on Tableau API authentication, or if you're new to the topic, I will include a link to the deep dive post that I did on authentication last year, and hopefully that'll help you get started. When it comes to permissions, another great thing about VDS is you don't have to do any additional setup at the site or pod level or server level. It's not behind any paywalls like Tableau Plus. It's just a feature that's baked in. It's already there for you now if you're on Tableau Cloud, and if you're on Tableau Server 2025.1 and beyond, it'll be available to you there as well. There is one thing that you want to double check on though, and that's just to make sure that the data sources that you want to query against have the correct permission set up for VDS. So if you look at the screen here, this is just our standard view of a data source in the UI. What I want to do here is come up to this ellipse for permissions, click on it, and go down to permissions. Now let's zoom in here. This is just the standard view, but if I zoom in here, let's take a look at this one. You may never have noticed this icon before. Looks like a little database with some curly brackets. That represents JSON, and it's labeled API access. And that just means the VizQL Data Service API. So in this case, any group or user that has the green check mark here, the effective permission for API access, will be able to query from this data source. And so once you've got those two things set up or ready to go, then you are ready to start making some queries. Before you dive in though, let's talk about how these queries are structured, how they work, and how you can get started. All right, so I told you we are just about ready to start writing our first VDS query. But before we go straight into that, let's look at the anatomy of a query to VDS and make sure that we understand what each part means. And that'll make it easier as we go along. As we start filling more and more out, we'll kind of keep track of where we are, right? So don't worry about the nitty gritty in what you see on the screen here right now. I'm just going to talk about the four outermost or the four biggest sections here. And that is the data source that you see on line 2, which is represented when you see these curly brackets, which is represented by a JSON object or roughly equivalent to a Python dictionary. This is where I'm going to specify the data source that I'm working with. We may need to specify credentials, which I'll talk about later. Those would also go inside of this data source object. Next is options. You're going to see debug true in most of my queries, which just means give me verbose information about anything that goes wrong. There are some other options that we can hide inside of this object, or we can place inside of this object as well. And I'll talk more about those as we go as well. Next query, this is the meat and bones, right? So the first thing we see inside of the query object is fields, and this has square brackets, which it represents an array, or roughly in Python, a list. And we can see that this is a list of objects. Each one of these objects contains key value pairs for field caption, for the first one, field caption, and in function in the second one. And we'll go more into what each one of those means, but this is where we are actually defining the fields that we want in our results. The last section of note here is filters. This is again an array or a list of objects. And in this object here, specifically, we are defining a numerical filter based on another field and the function that we want to perform. So again, we'll dive into each one of these sections and how to build them very soon here, but I just want you to have a basic understanding of the anatomy of these queries. It'll help us much as we go along here. Last thing before we actually write a query, I promise. But unless you've got a lot of extra time and you're maybe a little bit weird, you probably haven't memorized every single column in every data source that you're going to want to query, including its type and its actual name and other details like that. And you probably shouldn't, right? There's probably better use of your time. But you will need to know that information when you're making queries to VDS. So looking at the query that you can see on my screen, what we're actually doing now is hitting the read metadata endpoint. And I'm just sending it a JSON query that has an object called Datasource with a key called Datasource LUID and the Datasources LUID. When I send this request, what I'll get back is just a list of the names of the fields within this data source and their default, the name, the caption, the data type, logical table if it applies, the default aggregation, and so on and so forth. And you can see as I scroll through here, I just get an array I get an object that has a key called data, which is an array of objects that has all my field definitions. Don't worry too much about being so specific with those names. I just like to be precise. But this is how you would make an initial query to say, okay, here are the tables, or excuse me, here are the fields that are available to me so that I can start writing a query that's going to be successful. It's important to know, but I've teased you enough, and I promise in the next section, we're actually going to write a query. We finally made it. We're ready to write some VDS queries. Thanks for sticking with me here. All right, let's dive in. Check out the query that's on my screen now, on the left. We've got the data source section and the data source LUID. Heads up, I'm using variables in Postman here, and an environment just makes it easier. It means I don't have to show you all of this potentially sensitive stuff. The Postman collection will be linked in the description of the video. It's also linked in the blog post that accompanies this video, which is also linked in the description. So you've got ways to get to it. Just make sure and set up your own environment. If you're not familiar, check out the Postman docs. It's a very, very useful feature of Postman. Options, debug true. I want all the information if something goes goes wrong. So you'll see that in almost every query that we look at today. But let's dive into the query section and more importantly, the fields, right? So we can see that I've defined 3 fields by the fact that there are 3 objects in here. Each one of them has a field caption. Field caption key represents the name that you would see in Tableau Desktop or web authoring, essentially the display name for Tableau, but we call it field caption. If you take a look at line 18 for the 3rd field here, maybe I don't want the name to display in my results the way it is in the data source. Many reasons for that when we're talking about development or the web would be we don't really like things that have spaces or certain special characters. We would much prefer everything to be lowercase, separated by underscores, or maybe camel case in the case of JavaScript. But either way, field alias allows me the opportunity to give the field a name that it doesn't have in the data source, right? So let's hit send and see what happens here. So not surprisingly, I get back many, many results because if you notice, this query doesn't have any aggregation in it. So I'm getting back a JavaScript, a JSON representation of every row for every order in the data source here, right? So you can see on the right, I got order ID, customer name, date ordered, repeated over and over and over again. And that's fine. Maybe that's what I want. But let's look at the impact, of course, of adding aggregation into our results. So if I jump over to the next query, Datasource options the same. Now let's look at fields. The fields here that I'm going to ask for are region and sales. Now sales is a measure, so I usually want to aggregate that somehow, right? So if you check out line 15, you can see that I've defined a function, which just means, hey, Tableau, this is a measure and I want you to do something to it. Sales usually makes most sense to do something like sum or average, but any of the other aggregations that you're used to seeing in Tableau or SQL-like places like max, min, those sorts of things are also available. But for sales, let's just stick with sum. If I hit send on this query, now, unsurprisingly, I get 4 results. I get 1 for each region and then sales summed up and grouped by those regions. This makes sense, right? This is what we would expect. But I say this to point out that it's important to understand the level of granularity of your data and the fields that you're including, because if you're not careful, you could end up with many, many more rows that you want or many, many, many fewer rows than what you actually need. So let's just look at the difference that just one field can make, right? So if I look at the 3rd query now, you can see I've got region and I still have sales with a function of sum, but now I've also introduced state. And so let's send that and see what those results are. Now, obviously, for those of us who are very familiar with Superstore, we knew what was going to happen. But again, just to point out that now that I've introduced state, the level of granularity of this query has changed. And so now instead of getting 4 results, I'll get 50 something because there's every state in the US and some provinces in DC. But you can see I get a much longer list of results in here that I got when I left state out of the query. You can also see on the right, on the left, just to throw in, I've also sorted this data, which is really easy to do with VDS as well, just by adding a sort priority and then optional sort direction. Ascending is the default if I leave it out. But maybe I want them sorted by region and then descending by state, which is what you can see here. So that's an introduction to some of the more basic querying techniques. I hope you can see how they build on each other. And again, just it's important to understand how your data works to make sure that you can trust the results that you get back and that you're not having to do a bunch of extra math on your front end or back end. So in the next section, we'll talk about how to add your own fields. Just like when you're using Tableau Desktop or web authoring, right? You're going to run into scenarios when you need a field that doesn't exist in your database. We would typically just call that a custom calculation, right? You can do that in VDS just as easily. And oftentimes it's going to be much faster to let the VizQL Data Service do this calculation on the data than it would be for you to bring in everything you need and then do the math on your own, whether it's in your front end or back end. And then you're just getting back the data that you need. You don't have to worry about putting additional business logic inside of your application, which can lead to issues, right? So let's take a look at that. The query you're seeing on the screen now, so far so good, Datasource, options, we know all of that. Fields so far that we've got our customer, sales, I'm changing that to total sales, sales, and I'm using the function of sum on that. I also want to look at the last time this customer made an order. So I have the maximum of order date, and then I have last order date. So far, so good. We've seen all of this. But let's check out the last field definition here. So I've got a field caption, days since last order. We know what field caption means. Then I have something called calculation instead of function. When VDS sees this key, it is going, okay, so you want me to do an on-the-fly calculation or a custom calculation like what we would see in Tableau Desktop or web authoring. So if I go ahead and send this, I will get here a row or an object for every customer, their total sales, the last time they placed an order, or the max order date belonging to that customer. And then I have this field called days since last order. This data is kind of old, so these numbers are very large. But how did I do that, right? So jumping back over to the left, the calculation, date, diff, day, max order date, max today, that's just a calculation that you could write in Tableau Desktop or web authoring. The syntax is exactly the same. You'll get exactly the same errors if you do it incorrectly. So almost anything that you could write in Tableau Desktop as a calculation, you could write in VDS. I won't go into every single one of the exceptions because there is sort of a long list and scenarios that you can get into. Check out the VDS full documentation, which will be linked at the bottom in the description of the video as well. But for things like date calculations and what you would say simple math that can make your life a lot easier, you can create that field on the fly. It doesn't exist in your database, but it will exist in your results, and you just take it into your application and do what you need to do. So that's how you can create your own fields. Next thing we really want to talk about, right, is filtering. We don't always want everything. So let's take a look at how we can do that. Let's talk about filtering, right? In most cases, we don't want to just throw a large query at VDS and get every single result and then filter it out on our front end or our back end. We're kind of doing double duty there. Most cases, especially in web development or app integration, we want to filter by certain things. We want to slice and dice, and we already know that for the use cases that we need. So let's talk about some of the different ways that we can filter our data directly with VDS. Now, this is not an exhaustive list of the filters that are available. So again, I encourage you to check out the documentation that's linked down below. But these are some of the big ones, and then they kind of build on each other. So if you get a good familiarity with one, it starts to make sense how we do the others. So let's check out the query here that we see on the left. The first three sections should seem pretty familiar to us. We've got Datasource, Options, and then Query. So in this query, the fields that we're going to start with are state and sum of sales. And so we should expect the same 50-ish results we got before if we didn't add filters, which starts here on line 18. So inside of this filters array, I've got an object, and then I'm defining some things in here. So one of the first things I need to define is the filter type. And so in this case, I am doing a set filter. Don't necessarily get that confused with sets that we would talk about in Tableau Desktop. It is sort of the same, but not. It doesn't require that a set exists or anything like that. This is just the terminology that they are using here. So the filter type is a set. I want to filter on the field called state, and then I'm going to give it an array of values. So the values here, again, just a comma separated list of values in quotes. These are strings, so they'll be in quotes. And so I want Ohio and California. Now the exclude key, if you think about how that works in desktop or web authoring when you're filtering, this would mean if I were to set this to true, I would exclude Ohio and California from the results. But since this is set to false, let's see what happens, right? So I get sum of sales for only California and Ohio, which is what I would have expected here, right? So that would be the number one use for a set filter, just basically picking things out of a list instead of getting the entire list and filtering it outside of VDS. So let's look at another filter type here. So again, data source and options. This time, let's do customer name and count of order ID. So if we think about what I might be doing here, maybe I want a list of customers who have placed at least 3 orders. Let's play that scenario out here, right? So in my filters, now I have a filter type called quantitative numerical. pretty self-explanatory. But the next thing that I need to tell it is quantitative filter type. So I want a minimum. So in this case, my min is 3. So that what I'm saying here is that for the field captioned order ID, where it's being aggregated by count distinct, I want to return results that have a minimum count of 3. So let's see what happens when I send that query. Right? So I can see now I'm getting customer name and a count distinct of their order IDs, and all of these are 3 and above. And so that's a way that you can use a quantitative numerical filter to narrow down your results in a scenario like that. I also could do max. I could do other ones there as well. Let's talk about another type of filter that can be really handy, and that's a top N filter. So let's say that I'm looking for my top 5 states by sales, my top performers, so to speak. So checking out the first and second section, same things we're used to. In my query, I've got state and I've got sales, function of sum, and sorting descending. Now let's check out the filter section here. So what a top filter does, right, is I need to define the field, the dimension in this case that I want the top performers in, right? And then the field by which to measure that performance. In this case, that's sum of sales. Now the direction that you see on line 30 here, that can be either top or bottom, and that represents, do I want, the top 5 or the bottom 5? In this case, my prompt is the top performers, so we'll stick with top. And how many answers the question of course, how many results do I want? So let's hit send here. All right, as we totally expected, right? I got 5 results. They're grouped by state, and they are sorted in descending by the sum of sales. Perfect. Pretty easy one here, but very common scenario. Let's look at one more type of filter before we move on. And that is a date filter, a relative or a quantitative date filter here. These are very useful for things. Let's say we want orders that were placed in the first 3 months of the year. That might be something we're doing some sort of analysis on, right? So same stuff at the beginning, and my only fields here are order ID and order date. So when I go into here, now I want you to imagine the little sliders in Tableau desktop and web authoring that'll make this seem a little bit less technical than it is, right? So the filter type is date. What field am I filtering? Order date. And then the next thing that I need to define is the period type. In this case, it could be months, it could be days, it could be years. Check out the documentation for all of the options. But in this case, I just want months. And the date range type that I want is next N. I could do previous N or other options related to relative dates here. But what I want is the next set of periods relative to an anchor date. So how many do I want in my range N? That's 3. My anchor date in this case will be January 1st of 2020. Now I could also leave that blank and it would anchor to today. So it would be the next 3 months from today, which is a little weird, but I could go backwards as well. If I send this query, you'll see that I get a list of results, 1 for each order, but I can see that these orders were only placed in January, February, and March of 2020. This data is a little old, but that explains how you can use a relative date filter, what we might call a relative date folder in desktop or web authoring. So hopefully this is starting to make sense. Again, this is not an exhaustive list of all the different ways that you can filter. So check out the documentation, again, linked below. For more examples, but these start to build off of each other. And if you really start thinking about how Tableau desktop filters are working in the background, this is really just them represented in JSON. So hopefully this is making sense, and let's move on. So there are a couple other things to be aware of, a couple other scenarios you might run into with whether you're using additional options or you need to query something with credentials. So let's look at that first. So one caveat to know is that the VDS currently only supports data sources with a single connection that requires user ID and password. So if you have a data source that uses, let's say, Oracle that requires user ID and password and an Excel sheet, that's fine. You can continue. If you have Oracle and Postgres and they both require user ID and password, then you're not going to be able to use it with VDS at this point, unfortunately. Maybe that'll come in a future release. I'll certainly update this video and article if that happens, but watch the VDS docs for the latest updates to features and capabilities. But you can see on the left here, I've written this is a data source, a different data source, still Superstore, but that requires it requires a user ID and a password. So we wouldn't want VDS to just return that without specifying that information, right? So within the data source object, we can add another array, in this case, array of objects called connections. And inside of that, I've got connection LUID, connection username, and connection password. To get the connection LUID, you will probably want to use the REST API. You can also use Postgres if you still have access to that. But that would be a call to the REST API to get the connections within a data source, which will each have their individual LUID. And then from there, I'm just providing the user ID and the password, in this case, as a variable. So let's hit send. So with this plugged in, I get exactly what I would expect. If I didn't provide this, I would get an error that says something like invalid user ID and password for data source. So that's how you can query things with a single user ID and password connection. Also note that at this point, VDS doesn't support anything except for user ID and password. So if you're using something like OAuth or a token-based authentication, you won't be able to do that here, unfortunately, either. But hopefully that'll change. Next thing you might be interested in doing sometime, right? So let's send this query real quick and we'll talk about it. So far, this has been the format of every query that we've done, where we see in the results, we see an array, and each array has objects that are key value pairs. So we essentially get the field name over and over and over again in each object. 99% of people using this is going to be what they want. It's the easiest human readable, and most folks are really used to developing in this fashion. There are some web development standards and frameworks where what it really wants is an array of arrays, so a list of lists. It's a little bit harder to read, but it is, again, it can be what certain web components expect instead of an array of objects. So inside of my options here, if I change the return format from objects to arrays, objects is the default. So you'll notice it hasn't appeared in queries so far. So if you're good with normal JSON objects, you can leave it. You don't ever need to put this in. But let's see what happens when I change this to arrays, right? So in this case, I get back a list of lists, and each one of these lists is the same length, but instead of repeating the column or field names, each list is just the values. So in this case, I would need to capture, if I were going to display this somewhere, I would need to make sure that the field names that appear here are used as headers or whichever I need over here, because I'm not going to get my field names again. Again, most people probably aren't going to use this option very often, but that's the difference between the two, right? Now, the last thing I want to show is disaggregating data, right? Sometimes there are instances where we do want we do want a row for everything, and we may not want Tableau to aggregate for us. So in this case, let's change this for the example back to disaggregate false. This is going to give us sort of the standard thing that we expect, right? Since we've included the field caption, state, province, and sum of sales, we're going to get, again, approximately 50-ish results. If I turn this disaggregate to true and run the same query, what I'll get is a row for every that it just includes state and sales for each and every one. And I can tell that this has been deaggregated, right? Because I have Illinois appears multiple times. So there may be instances where we want to do this. This is just kind of a flimsy example, but if you're used to unchecking aggregate data in Tableau Desktop or web authoring for your use case, this is exactly what that's doing as well. So hopefully the information in this video has helped you start to wrap your mind around how VDS works, how you can write queries for it, and the different ways that you can slice and dice your data. But in addition to the Postman collection that's linked down below, and in the blog post and the video from last year where I show a little bit more of the art of the possible with VDS, I also wanted to leave you with one more gift, and that is a little tool that I put together here that will make writing these queries a more visual experience, because let's be honest, writing that much JSON, especially if you're doing it over and over again, or if you have queries that need to include many, many columns, it can be quite tedious. If you're doing it by hand, it can also be a little bit error prone. A stray comma or quotation mark here or there can really mess you up, and it can take a while to find it. So this is available at kylejmassey.com/VDS-utility. So let's get started and see what we can do here. So if I click on Get Started, first thing it's going to ask me to do is log into Tableau. So this is available for anyone on Tableau Cloud. Unfortunately, it would not be able to give this access to any server instances, but for Tableau Cloud, we can go ahead and sign into our site here. I do want to call out that nothing in terms of credentials or data is being saved by this app. It's all just in your browser. But if you are more comfortable with running this locally, you click on the information icon in the top right, you can get the link to the GitHub repository and run this on your own. So anyway, now that I've got my credentials entered in here, I'm going to click on Next, which will go ahead and log me in. The next thing I'm going to be presented with is to choose a data source here, right? And so because oftentimes you have many, and the data, the name may be repeated, it's got the project there for you as well. So I'm just going to look for one we know well, which is Superstore. I click that. And then on the next screen, it's going to give me the opportunity to start adding fields. And so what did it do in the background there? It ran our metadata query that we showed at the very beginning. So now if I click on the plus here, I can actually see the fields and I can start interacting with them here. So let's keep this nice and easy. Let's go down to, let's grab state and sales. Now, I don't want just a row for every order that includes a state and sales. Let's go ahead and take care of summing this up. So I can do my function right here, right? So I can click OK. I'm satisfied with those two fields. If I wanted to, I can add and remove from the query just using these buttons. Let's go on to the next screen, which is going to be the custom field screen. And let's say I want, just for clarity's sake, the maximum, the largest order that any state has ever seen. So I can do a custom here, and I want to do the custom alias of largest order. Now I could also define this another way, which would just be to select sales and do the max of it. But this also shows you how you can use custom calculations in addition to this. So I'm choosing a custom field. The alias is largest order, and then the custom calculation is max sales. And I know that's going to work because I understand, again, the granularity here. So then if I move on to the next one, I have my filters. So let's do a top filter here. So let's do a top N. What I want to measure here, or what I want to return here, is the states with the sales, sum of sales, and we'll do the top 5. And I can add this to exclude, and I can make this a context filter. I'm not going to do that here, but I can do that for other scenarios if needed, and add filter. Next, on the next screen, I can do two things. I can view the JSON that is actually running this query, and I can preview the results. So if I click on preview results, what I'll get back here is just a very simple tabular representation of the data. I can kind of do a quick spot check on, like, does this make sense? It seems like it does. So I can close this, and now I can grab the JSON directly from here, throw it into Postman or into my web application, and use it moving forward. So feel free to use this, try to break it. Any feedback, anything you have related to this tool, I really want to hear. I want to make it better. I want it to make VDS easier and more attractive. So definitely let me know what you think. So that's it. That's the end of the video. I want to thank you so much for sticking with it. And I really hope that this video has helped shine some light on exactly how to use VDS, how you can get started, how to write your queries. I hope you'll use the little utility that I put together and give me feedback on that. I want to know how you're going to use VDS, right? You know me. I've been a fan of this for a long time, since even before it was in beta and be able to be touched last year. I've been excited about this for a long time, so I'm really happy to see it make it all the way to GA, and I can't wait to see what you come up with. So as always, leave me comments below, comments on the blog post, reach out to me on any of my socials, which are linked on the blog post. I want to hear from you. This is something that I've invested a lot of time in personally, and I hope that other folks are starting to see the magic of VDS as well. So again, I just want to thank you for watching the video today. I hope you have a great rest of your day or evening, wherever you are in the world, and let me know what you think. Thank you.